Hey Harsha, did you post this doubt in the doubt solving session? Okay. So I'm explaining it right now, and then I'll be again explaining it next week because this is a course content which belongs to week number 6, right? It was posted in week number 6. Okay, so in detail, I'll be covering in the next doubt solving session. However, right now I can explain that what you have written is completely right. That the volume fraction of matrix is always 1 minus volume fraction of fiber if we assume that the void fraction or the percentage of air voids present in the composite are 0. So in the question itself, it was given that the fiber volume fraction is 50%. So it is equivalent to 0.5 and therefore 1 minus 0.5 is also 0.5. Therefore, this is the term which sir has used. If it would have been 0.2, then your Vm would have been 0.8. Fine? Okay. Fine. Fine. Okay. Um, do you have some doubts in assignment number 4 solution which were posted? No. Okay, for future reference, I can explain so that students who are not attending this particular doubt solving session can see them all on YouTube. So in assignment number 4, the first question was that which of the following is not true for a filament winding process. So first let me show what is a filament winding process. So this is a typical filament winding process. This is the mandrel surface, which is the base on which these fibers are getting wound. So fibers in definite angles wound across the cylinder in a particular direction for one particular layer. And then once the entire cylinder surface is covered, then slowly, like layer after layer, the composite are wound over each other. And finally, we have the complete composite which is wound. Fine. This is the overall like short summary of what a filament winding process looks like. There are long fibers all wound together on a particular mandrel surface. So in this particular question, they have asked that which of the following is true for filament winding process. So the first, which is it is not possible to produce part with reverse curvatures, it's absolutely true because you can see here there are like this is the basic mandrel surface and fibers would be wound at these particular angles. The angles can be a little more different, but more or less it will start from one end and they'll go towards the other end. So if we have curvatures in this particular surface, then fibers are all under tension. So fibers will remain taut and the base surface would somewhere fall quite low as compared to the main composite part. And therefore, for structures with convex, no, actually concave, structures with concave structures would have a lot of air voids in between and therefore they cannot be wound using filament winding process. So first is true, it is not possible. Then the second one is fiber direction cannot be changed within a layer of winding. So yes, for filament winding, a particular layer has fibers oriented in one angle only and therefore changing the fiber direction is not possible. As seen here, all these fibers in this particular layer would be in this direction only. So therefore, all the fiber directions are same. It would be plus or minus. That is, a cross structure would appear. However, the angles will remain the same. Then the third point states that composite product configuration should be such that it should facilitate in mandrel extraction. So as seen in this particular process, we have already fixed this initial solid surface inside the composite structure. But if we want to extract this particular solid surface from within, then for that we use collapsible mandrels. So it has lot of like wires and structure so that we open screws, and as soon as the screws are opened, that entire mandrel converts itself into straight lines and they easily get extracted from these particular openings and only the composite part is remained with us. So therefore, it's very important if we want to manufacture only composite using filament winding process, then mandrel extraction should be kept in mind. And therefore, this option D, that is 1, 2, 3, all three are correct. Then the second question was about which kind of flakes can be used for coatings. So it's aluminium. It's a very common property of aluminium that it gives high surface finishes and has high resistance to chemicals because it forms an oxide layer over itself. So that's why it's used as a sacrificial material and is preferred for coatings for high surface finishes. Then this is a question in which they ask that out of sheet molding compounds and dough molding compounds, which will have higher mechanical properties. So these are the comparison between dough molding compounds and sheet molding compounds. We can see the uniformity for sheet molding compound is very high as compared to dough molding compounds. In these one we have long like short fibers. They're all bunched together in a like random amount of resin, and in this one it's a uniform arrangement of very long fibers all stacked together uniformly. So therefore sheet molding compounds will have very high strength as compared to dough molding compounds. One is because they are more uniform, well oriented, and the second one is that fibers are quite long, so the load transfer is very easy when we talk about sheet molding compounds. So therefore a and R both are true, and R is correct explanation because the fibers are longer, so load sharing would be easier. Then the fourth question was about why are ceramics sensitive to thermal stresses? So, as we see in the stress strain curve of all the materials summed together, we see Al2O3 is a monolithic ceramic. So, mainly ceramics are crystalline structures. We can see here, this is Al2O3. It has highest tangent. So, this tangent high means high modulus. When we compare it with metals and polymers, then we see that ceramics have highest modulus because they are crystalline in nature. So what they are talking about here is how is their thermal stress uh, like low as compared to metals and polymers. So the reason behind this is its crystalline structure. It's well known that ceramics are crystalline in nature, while amorphous like oxides of metals are normally called glasses. So ceramics have strong bonds and they have light atoms which like are clubbed together in a definite crystalline structure. So as soon as you apply little amount of energy, these bonds and atoms start vibrating heavily. So if you're bringing a huge thermal stress, that is you're rapidly cooling a particular ceramic, then in those cases, lot of energy dissipation would be seen. So as soon as you see energy dissipation, then in those cases these bonds which are present will start breaking, and therefore whenever you suddenly cool down a particular ceramic, then there are lot of chances of occurrence of cracks and failures because their bonds are all covalent, so it's irreversible, and also in small disturbances the bonds heavily vibrate, that is with high frequencies, therefore the chances of failure are very high. Fine. And then the fifth question was about what is the like need of bleeder plies in bag molding process. So as seen in the schematic here, plies are used for absorbing the excess resin, which is sucked out from the vacuum pump, and therefore the main cause is absorbing the resin, while breather plies are for absorbing the air molecules. So breather will help the composite breathe, and bleeder will help it to stop the excess resin which is coming out from the composite. So that's why the answer is B. Then the third one was which of the following fiber is most suitable for personal armor. So this I've already explained a lot of times that glass fiber is cheaper, has average modulus and is highly used in commercial applications. Carbon fiber is very low weight, it has very high strength, but is very costly. So it's only used for extremely high performance applications which requires high strength. Then ceramic fiber have insulating properties, so they're mainly used for high temperature applications. And aramid fiber has high abrasive strength. That is, even after giving a lot of wear and tear, they'll still function properly. That's why they're more or less used for personal armor applications. Then this is the match the column for different like ceramic reinforcement in metallic matrices. So based on the applications and the properties of these particular reinforcement, we'll choose which of the following is the best application for these particular cermets. And we can see tungsten carbide, it has high wear resistance, and therefore it is used for heavy load applications. And apart from heavy load applications, it can also like perform well in very high temperatures, and therefore for wire drawing purposes it's used because its accuracy and precision is also very high. It's also used as ultra high precision too. It can compare to diamond when it comes to performance. Then chromium carbide is a refractory material, and it also has a high strength and has good corrosion resistance, and therefore chromium carbide is used for wall part and high load bearing applications, because in this particular part 2 there are very small parts and you need a lot of resistance, and it deals with water and liquids, so you also need chemical resistance. So therefore when you are like placing them into pumps which mainly has metal parts, then we need some parts which would be completely corrosive resistance and also has high strength at the same time. So therefore chromium carbide is a good solution. Then titanium carbide is mainly used as a cutting tool, and it is also used for high temperature applications, for which it is a part of torch tips and hot mills. This is quite simple. You just need to search online that what would be the application of these particular reinforcements, and based on that you can simply match these. Then fourth one was that which is this fabrication process. So out of all these present, pultrusion was the only one which is automated process, and this schematic itself states that it comprises of a like completely automatized process. We can see the fibers start from here. They heat, then resin also placed inside. Then they heat simultaneously. It's being pulled out, and then after curing, it's even like cut at the same time. So we can see within the single process we are able to obtain finished process all in an automatic way. So this is what pultrusion stands for, and therefore this is pultrusion process. So which of the following is true for stray layer process? So stray layer process is in which we place the reinforcement mats properly, and then we just spray the resin over it. So in that particular case, the extent of resin which would be added on that reinforcement material can vary a lot, and therefore the amount of resin which is there on that reinforcement materials is very high, as the resin density is quite high as compared to reinforcement in case of carbon fiber and aramid fibers. So for performance point of view, they're excessively heavy. Instead of spray layer process, if we want lighter composites, then we would prefer filament winding process or compression molding process, or processes in which resin is always there under a pressure gradient, so that minimum amount of resin is present in the composite. Then the second one states that short as well as long fibers can be incorporated by this process. So it's wrong. Only long fibers can be incorporated because we have mats on which the or continuous unidirectional fibers on which resin is just sprayed. So if you are using short fibers, then it will not at all make a sense. It would be difficult to mold it, and therefore long fibers are mainly used. Then as we are spraying this resin, the viscosity definitely needs to be low, and therefore 1 and 3 are correct options. The 10th one is quite interesting. In this one, they have asked that which would be most suitable for vacuum bag molding. So if you remember the process, this is the schematic. Vacuum bag molding comprises of laying the mold, the reinforcement material, the bleeder plies, the sealant tapes all well together, and then using vacuum pump we create vacuum and then start infusing resin into the system. So the first requirement is that resin should properly infuse through the entire system, so the viscosity needs to be low. Apart from that, the resin should also consolidate well. Proper vacuum should be applied on the entire surface through all the peripheries of the composite, and after that it should slowly start curing. So in that case, it's quite important that the resin should not cure or harden before this entire process is getting completed. and therefore the gel time of the resin plays an important role in defining that which kind of resin should be used for this particular process. Out of the three given choices, polyesters and vinyl esters, these both have similar properties. We have a hardener, we have a resin, and we also have an accelerator in polyester and vinyl ester resins. We mix all these three compounds together, and within minutes, these resins start curing at room temperature itself. So they'll completely harden. After suppose 1 hour, you'll see the liquid resin has completely converted itself into a solid like structure. But in case of epoxy resin, their room temperature cure and some even go up till 24 hours before they completely harden. So therefore, for vacuum molding purposes, we prefer epoxy so that this entire process of like first infusing the resin through this entire system, then sucking out the excess resin, and then like giving extra vacuum so that all excess resin is well consolidated and squeezed out of the system. For all these particular applications, we prefer epoxy because it has low gel time. Fine. Any one of you has some other doubt in this particular week? If not, we can end the meeting. Hello. Does anyone of you, does anyone you have some doubt? For those who join late, it's not at all an issue. If you want to look at this lecture, the like you can see it here, this problem solving session. Once you click over it, you'll have. Oh, this is not displaying right now. You'll have like a Excel sheet. So that particular Excel sheet will have link to YouTube. Like videos of this entire doubt solving session. So if you have missed a particular session, I take a session on every Monday 6 to 7. If you have missed anything, you can just visit that particular week's YouTube link and you will get whatever I have taught from the starting till the end. And apart from it, if you have any particular doubt, you can just post it on that NPTEL's Ask a Question forum, and I'll be discussing those doubts in this particular class. Okay, fine then. Meet you all on next Monday. Thank you. Yeah, say. Okay. What was your doubt? Can you recall it? Yes, yes. High strength. Right. Yeah, I have explained it in week two's problem solving doubt only. You can go there and like refer it. You'll easily get it. As soon as you, like told you the place where to find it, right? You'll click over it. You'll get a Google sheet. So in week two's link, you'll click it. There is a like that doubt has been discussed in that particular video. Fine. If you have any doubt further, then you can again post that doubt. I'll cover your particular doubt in the next solving session. Fine. Okay, then meet you all on next Monday. Thank you.